Welcome back to the channel. Today I'm gonna tell you all about the glide ratio and why this feature is really important when talking about aerodynamic performances. Let's go. So, let's start with the definition itself. This is kind of my interpretation of the definition. This is not something you find in the books, but anyway, it works. So, if you don't do nothing, how long can you stay airborne before crashing to the ground? This is, let's say, my interpretation of what glide ratio really is. If you want to look at the formula, we have the ratio between horizontal and vertical distances. So what that means is that glide ratio is one of the most important metrics when evaluating the performances of any flying objects, from airplanes to parachutes to paper airplanes, whatever. It provides a simple but powerful way to understand how efficiently an object moves forward compared to how much it descends. So let's take, for example, this wing section. Okay, we have the vertical and the horizontal distance. Based on the shape of the wing itself, we can assume different glide ratio. For example, if we have a ram air parachute and we move 3 meters in the horizontal distance and 1.5 meters in the vertical ones, we obtain a glide ratio of around 2. And I wanna, let's say, give you a quick example right here. In your opinion, between these 3 different shapes of wings, which is the one that has the highest glide ratio and why? The delta wings, for example, the Aerofighter, commercial airplanes, or the Spitfire, the plane that the Germans had during World War II. Anyway, now you know what glide ratio is, but why this number is really important. So, if we move forward with another example, I'm gonna give you 3 different ways of why this number is really important. But what happens if, while your friends are making the landing inside the landing zone, you accidentally open your parachute too far from the drop zone and you don't know if you're gonna make it inside the landing zone? In this condition, if you know your glide ratio, this can really help you make it inside the landing area. Why? For example, you're flying over buildings, or if you're jumping with your parachute in Florida and you land on water, there is a big chance you're gonna meet one of these guys, and that's not good, and you know that. So, since you know your altitude because you have an altimeter with you, and if you know your glide ratio, let's say it's 3, you can easily calculate if you're gonna make it inside the landing zone or not. And if you're not, you gotta to figure out where to land, and you know you don't have to land into buildings or in water. So knowing this number is a very safe thing that you can do before jumping with your canopy. Example number 2, do you remember the film Sully, where the pilots had to land the plane inside the Hudson River? Yeah, that was a bird strike incident. So that means that birds are crashing into the engines of the plane itself, causing the plane to, in that specific case, lose both engines. So the only thing that the plane can do to make it to the airport is glide. That means knowing the number of your glide ratio. So, for example, if you are flying with your plane, you have a bird strike, I hope not, you lose both engines, you gotta know how much can you fly horizontally while losing your altitude and making on time for the landing in the airport itself. Example number 3, this is another example for engineers. So when you have to design a wing, one really important aspect is design the most efficient wing possible. That means you've got to be able to create some kind of lift distribution over the wing that can increase the lift and minimize the drag. In other words, that means that you minimize the energy losses and you extend the range of the plane. And that can be traduced with having a higher glide ratio. Okay, so that's really important for designers. Now I'm gonna give you some examples of different glide ratios. So let's start with skydiving and in the specific case of a wingsuit. So wingsuit, as you know, is a person inside a suit that tries to replicate the behavior of a bird. So usually when a skydiver flies with a wingsuit with the parachute still closed on your back, so that means just the shape of the parachute plus the wingsuit, they are able to fly with a glide ratio 3:1. That means that they can fly 3 meters horizontally and lose just 1 meters vertically. If you move to example number 2, when you open your ram air parachute, depending on the shape, the size of the parachute itself, we can go from 1.5 to 5 in some cases, and it also depends a little bit on the ability of the pilot inside below the canopy. So it's a range that can move to 1.5 to 5 in some cases. Example number 3, we have paper planes. I don't know if you have never seen any competition of these guys making the most amazing paper planes, but I'm sorry, I have no idea the glide ratio of these flying objects. Example number 4, we have commercial planes. We usually are higher than 15. It's really hard to understand the real number because factories like Boeing or Airbus, they don't wanna let you know this number because for a designer that means understanding how efficient the wing is. Anyway, last but not least, we have glider. So this is the perfect example of how efficient something can be without using engines. So as you know, the glider uses just its shape to fly as efficient as possible. They usually go higher than 40 or in some cases even higher than 50. That means that they can fly 50 meters losing just 1 meter of altitude, and that's incredible, and that's a really fantastic job of aerodynamic of this wing right here. That means that this kind of flying objects have really small energy losses because the shape of the wing and the fuselage is really optimized. So I hope you guys find this video useful, and if you want to see something like this, more video like this, you can find all of those in my channel.